right, you guys, Mrs. Wagner here, and I'm going to show you how to do energy bar charts. So let me bring this up a little bit closer, you can see it better. And all right, energy bar chart. So what an energy bar chart shows is energy transfer of a system, okay? And sometimes we call them LOL charts. As you can see, it does kind of look like LOL, laugh out loud. So if we ever say we're going to do LOL charts, we're talking about the energy bar charts, okay? So energy bar charts show transfer of energy in a system, okay? So let's start with what's the system? What system are we talking about? It depends on the scenario. So you've got to read what the scenario is. What is it that we're talking about? This says some water spilled on your shirt evaporates. So we're talking about an energy transfer in water. So water is considered the system in this particular scenario. And the energy transfer happens between the water and really specifically the shirt. And somehow the shirt got some energy and now is transferring its energy to the water. And then the water begins to evaporate. There might also be another kind of transfer of energy with something else that the water is coming into contact with, like the air, okay, or even radiated energy from the sun. So we're talking about water, and that is going to be our system. So in an energy bar chart, the O is what we consider the system. So we're going to label that, and that's the first thing you need to do is figure out what is the system that the energy is either coming into or going out of. And in this case, it is the water, okay? This also can show energy flow. So on our bar chart or our LOL chart, we want to indicate that this is showing the energy flow. So is the energy flowing into the system in the scenario, or is energy flowing out of the system in this scenario? Okay, so let's take a look at the entire scenario. Water spilled on your shirt evaporates. So here we're talking about water evaporating, okay? And we already know that evaporation is water turning into a gas. So liquid becoming a gas, water becoming water vapor. All right, and what's the energy transfer that has to happen here? So do you think energy is coming into the system, the water, in order for it to become a gas? Or is energy being taken away, going out of the system or out of the water in order for it to become a gas? Well, we learned if something's going to go from being a liquid to a gas, that the molecules are going to speed up. They're going to start kind of going quicker and bumping into each other and creating more space in between each other. In order for the water molecules to move faster to become the gas, they're going to need more energy. So just like us, if we're going to go from walking to running, we're going to need to increase our energy to do that. And that's what water particles need to do as well to become the gas. They need energy added to them to become the gas and be able to go faster, okay? So how do we represent that energy flow on the bar chart? It's real simple. We're just going to use an arrow. We're going to show that energy is going into the system, okay? So our little arrow shows energy flowing into the system in order for it to become a gas, okay? All right, so now let's show what that energy transfer looks like from the initial temperature to the final temperature of that substance or of that H2O, okay? So initially, as a liquid, is it going to be more or less than the final? That's what we need to decide. But let's talk about what these letters down here mean. This is ETH and ECH. And the TH actually means something, and so does the CH. E, do you know what that means? That's energy, okay? So energy can be either from thermal or it can change chemically. So energy can change in a thermal way or as a chemical way, okay? Well, we're talking about a phase change here, okay? We're just going from a liquid to a gas, and that's a phase change. And the only thing that's occurring with the molecules there is that they're just they're just changing their speed and they're changing their spacing in between each other. Nothing's actually happening to the molecule itself. So that is considered a physical change, not a chemical one, okay? So TH actually means thermal, okay, which is a thermal change, a change in thermal energy, whereas CH is chemical. And that would be a different kind of change. That would be more like a chemical change. And we might deal with the CH during the chemical change unit when we do more chemistry. But for now, we're really just dealing with thermal changes. So we don't even need this. We're just talking about a physical change of this substance, okay? Going from a liquid to a gas is just a physical change, not a chemical one, okay? So we'll just ignore the ECH. If it's on your document, you can just ignore it. You can leave it on your document, but you're not going to be showing any bars above that part. It's only going to be above the TH since we're showing a thermal change, okay? All right, so from initial to final, what would you say? Is there more or less energy in the initial than the final? Well, if it's going from water, liquid to a gas, it's going to have less energy as a liquid at the initial than it is as a gas for the final, okay? So we've got to show the energy being smaller in the initial and larger for final, okay? I think in the PowerPoint, we said that if it's a liquid, we're going to use 3 bars, right, on the energy bar chart. So that would be 1, 2, 3. Right here, so we can show the amount of energy in the liquid as 3 bars, okay? The important part will be the comparison. We want to make sure this has less energy than the final. All right, so it's a liquid, energy moved into the system, it evaporated, became a gas. 1, 2, 3, 4, 5 is what we're going to show over here to show the amount of energy now that these molecules have as a gas. It is more than what they were as a liquid, right? Okay, so that works. Now, if the liquid was turning into a solid, so let's say it was not going from water to water vapor, so let's say it was not evaporating, let's say it was turning into ice, let's say that it was freezing, we would want to show energy going out of the system, okay? So we would show the arrow moving out if it was a freezing, water was freezing. Okay, so just you might have some of those where energy is being removed and you would just show the arrow going out. And if that was the case and energy was being removed, then your initial temperature would be higher than your final, okay? Because it would be water having more energy as a liquid, energy is being removed, and then it would be as a solid, be freezing, it would have had to have lost energy, so it would have less. It would have lost its energy to the environment, okay? But this case, energy was added, going from a liquid to a gas. One other thing you're going to have to do is you're going to have to represent this in a pictorial model. So this is more like a graph model, it's still considered a model, but we're going to use now pictures, okay? Because that's another thing that you have to show. So we're just showing the molecules, what it looks like with the molecules. All right, so I'm going to draw 2 circles here, okay? And this is going to be the liquid. So I'm going to show these circles kind of closer together, still random. We do need to show their speed. So in this case, 2 swooshies. I don't know if you can see that I'm adding 2 swooshies to these circles, okay? But that's what I got going on there. 2 swooshies over the circles to represent the liquid, okay? Now, energy is being added to the system to go from liquid to gas. So we're going to show the energy, all right, being added into this substance, and that turns it into a gas. Put them kind of spread out. Now they're farther apart. They're moving quicker to be that gas. So we're going to do 3 swooshies to represent our gas, okay? Liquid to gas, energy being added there. All right, so that's what you need to do on your energy bar charts. Remember, energy can either be going into the system or it could be being removed out of the system. So This is when it is being added to the system. If energy is being removed, then you would have a bigger bar over here and a smaller bar over there. And then what do you think would be happening with the arrows? We would be having energy the other way, okay? So if it was going from a gas to a liquid, I'd want my arrows to go that way, okay? Because I'm removing energy from the gas to become the liquid, okay? Hopefully that makes sense. Talk to your teachers if you have any questions. Have a good day.